For those of you who are just joining us, I'm Kathy Dello. I am with the Climate Impacts Research Consortium, or CIRC, at Oregon State University, and I'm one of the people who's been working on this Pacific Northwest Drought Early Warning System, or the DEWS, for the past couple of years. So we've been having these bi-monthly webinars, even though there's no sign of drought in the Northwest, to keep our people up to date on climate conditions and talk a little bit about relevant research to the DEWS. So I'm going to pass it over to Amanda Sheffield, who's actually down at Scripps and is helping us out for now to kick us off.
Thanks, Kathy. As she said, my name is Amanda Sheffield, and I'm one of the new coordinators for NIDIS for the Drought Early Warning System. Specifically, I'm working with California and Nevada right now, but I'm happy to be here and help Kathy run these webinars. She and others have set up a great agenda for you all today with an update on the current conditions from John Abatsoglu. Kathy herself will be giving the climate outlook. The USDA Regional Hub will have an update, as well as some information on a seed lot selection tool from Gabrielle Roesch McNally, and then Chris Schnepf from UI Extension will be talking about adapting to climate change, comparing forestry and agriculture. Before we get into that, this is just a quick reminder for those of you that have joined before and those that haven't about what is the National Integrated Drought Information System, which works with these webinars with Kathy and others in the region. They provide a better understanding of how and why drought affects society, the economy, and the environment. And the goal is to improve dissemination and use of drought early warning information. And the way NIDIS has done that is build off regional drought early warning systems to create a national drought early warning system, because they realize that drought is different and very different in different parts of the countries with different concerns, issues, information use, and capacity. So with these regional drought early warning systems, they're working with communities and existing networks to build capacity for better drought planning and drought mitigation. These include different parts, including research and monitoring, drought and risk assessments, drought and climate outlook forums, webinars such as these, other things such as web portals, social media, new and existing communication networks, all related to the different core pieces of regional drought early warning systems. In the Pacific Northwest, as Kathy mentioned, this is part of a webinar series that is all part of linked off to the activities in the Pacific Northwest, including the official launch in February 2016. And currently, in the last 6 months, a strategic plan has been under development and is under different levels of review, identifying existing and new drought-related activities in the region. And it's meant to be a living document or a living reference of activities in the region, so that over a 2-year time frame, we can set goals and activities and related to drought early warning in the Pacific Northwest. And the priority areas include improving monitoring and research for drought risk management, expanding drought early warning communication and outreach, optimizing information in collaborative networks, and enhancing drought planning and mitigation. And the last slide here is just to mention, as Kathy said, these are a part of a series. So the next webinar is August 28th. Obviously, then we'll start to think about the next water year coming up, and you can register now, or you'll also get information through email later on. And that's all the slides I have, Kathy, so should I go ahead and pass it over to John?
Yeah, so John Abatsoglu is a climatologist at the University of Idaho, and he's one of our CIRC team members and one of the leaders on the Northwest Climate Toolbox, which has shown up in a number of our slides and is funded in part by NIDIS and CIRC and the Northwest Climate Hub. So John, I'll let you take it from there.
Okay, thanks, Kathy. So thanks everybody for tuning in to our discussion on drought. And it's somewhat ironic because, as Kathy mentioned, there is no drought in the Northwest to speak of right now. And we basically have had our wettest water year in around 20 years for the Northwest. So my job is to give you a little bit of the play-by-play in terms of what's transpired this winter and spring, and basically has led us up to where we sit today. And we'll just get right to it. So on the right-hand side here, this is not a blank map. This is the map that was depicted by the U.S. Drought Monitor last week. It's not blank. Rather, what has happened is that the Drought Monitor authors have used their white crayons to basically color in the Northwest. We are drought-free. This is the last time we were drought-free in the Northwest, depicted by basically no level of drought, was 2011. We've seen quite a bit of drought abatement in terms of where we were 2 years ago. If you recall, 2015, we had a pretty significant snow drought followed by a really, really warm, dry summer. Even last year at this time, we had drought, some level of drought across much of the Northwest. And the reason, of course, for that is that it has been incredibly wet across the Northwest. The water year to date, I'll give you a little bit of information on that in the next picture here, but this is just for spring. Across much of the Northwest, much of the region experienced their, sort of a top decile, wet spring. And a couple regions, including areas near Spokane, some of the sort of areas from the Washington coast down to northwestern Oregon, the wettest spring on record as well. Temperatures were not nearly as warm as some of the springs that we've seen over the last couple years, but by and large, over most of the Northwest, particularly portions of the interior Northwest, it was a bit warmer than normal. There are a couple exceptions. The Columbia Plateau has struggled to see above normal temperatures, although that has certainly changed a bit. So this is where we are in terms of our current water year precipitation. This is from the Climate Toolbox product that we are working on through the CERC project. And what we can see here is a lot of green. That's really the color of the day here. Above normal precipitation, like I mentioned before, this is basically the wettest water year. If you basically consider the states of Oregon, Washington, Oregon, Western Montana, you average all that together. More or less the wettest in 20 years, the fourth wettest water year to date since 1895. There are a couple locations that are basically going to make a run at the wettest water year to date, or wettest water year total. So again, the water year goes from October 1st through September 30th. We have about 3 months left of the water year, but we basically, climatologically, 90 some odd % of the precipitation has fallen. But I wanted to just highlight a couple areas. We'll look at Seattle, the SeaTac Airport, Seattle, Washington, also Pocatello, Idaho, very, very disparate portions of the Northwest, both posed to actually make a threat at the all-time wettest water year. So this is just some numbers from October 1st through present. Seattle, SeaTac is, 3 inches shy of their all-time record. Pocatello's about 2 1/4 inches shy of their all-time record. And of course we have, whatever, 90 some odd days to see if we'll actually make a run at that. Either way though, it's been an incredibly wet year, and we are drought free across the United States as depicted by the US Drought Monitor. Now there have been a number of impacts across the Northwest due to the basically too much of a good thing. We have seen flooding concerns ongoing across much of central Idaho, and that's basically a consequence of having a pretty impressive snowpack that built up into the spring months. And then we had some really, really warm temperatures. So we had rapid meltouts, and the Big Wood River in Blaine County, Idaho, that flows through Sun Valley has been at or above flood stage for a majority of the time for the past 50 days or so. So the snow melt flows over the past few months have certainly had dam operators on edge. This is a snapshot from Shoshone Falls near Twin Falls, Idaho, and some pretty impressive flows coming down. Now, the question is exactly, what was responsible for this, onslaught of moisture and also the cool temperatures that we had across the Northwest this past water year. And there's a couple potential ways to explain that. One is we had a relatively weak La Niña. I think it was just marginal enough to qualify as a La Niña per NOAA standards. And certainly the Northwest generally ends up being wetter and cooler than normal during a La Niña. So that's a little bit of what potentially has gone on. We've also had more or less an onslaught of atmospheric rivers, these big moist systems that, bring torrential rains across basically from British Columbia all the way down to California. They have been impacting much of the West Coast this winter. Somewhat different from a La Niña, where we typically see wet conditions in the Northwest, dry conditions in the Southwest. It's been a little bit different this year. And so I think the combination of this sort of weak La Niña along with the sort of onslaught of atmospheric rivers has been responsible for the pretty widespread precipitation, heavy precipitation, above normal precipitation, basically from Central California all the way up to into Canada. This is showing us the 500 millibar height anomaly from October through May of this year. And this is telling us a little bit about the temperature of the atmosphere, a little bit about circulation patterns. What we're looking at here are the departures from normal. So that big purple blob off the Washington coast there, that is depicting well below normal heights, which is indicative of a much cooler than normal air mass. It turns out that over the entire northern hemisphere, this is the most anomalously below normal heights that you'll find in the northern hemisphere, and that's responsible. That's very much associated with the below normal temperatures. And Washington State is the only state in the U.S. that has had below normal temperatures for the calendar year to date. But another interesting thing is that this map tells us a little bit about circulation anomalies, and so that purple blob there you can think about as the cyclonic anomaly, and the flow around that is more or less counterclockwise. And so you can imagine that when we have this sort of a southwest fetch of moisture, that's going to bring in more of that moist air, and that's going to contribute to a lot more of the precipitation that we have seen across the region. There have been another couple interesting impacts from the above normal precipitation. This is from Climate Engine, which is a product that has been partially sponsored by the California Nevada DEWS and the Northwest DEWS, looking at sort of mapping climate and remotely sensed indices globally. But here we're looking at basically the normalized difference greenness index or vegetation index over the past 30 days relative to normal. And so again, this is sort of an anomaly map. The reds that you see are basically areas that have had snow cover this year that basically didn't have or had less in previous years. So that's clearly the mountains. But what I wanted to draw your attention to is all that green across the Great Basin, including the Columbia Basin, the Snake River Plain here. And that's basically corresponding with this really impressive green up of, our rangeland system. So huge amount of grasses growing, very, very vigorous. And a couple interesting things you'll also see in here. We have seen a relatively cool start to winter and basically the calendar year across particularly the Columbia Plateau. And that has actually led to a delay in a lot of the crops across the region. So the sort of speckled features you'll see here, especially across sort of the Palouse area here in eastern Washington state, that's indicating below normal greenness. That's because we've had a delay in the phenology and some of the wheat crop is late to start up. Since this is a discussion on drought and drought early warning system, even though we have no drought per the U.S. Drought Monitor, and it has been above normal in terms of precipitation for the water year to date, the reality is that things have changed a bit over the last 30 to 60 days. We've certainly had some warm temperatures that has been associated with rapid snowmelt. We've also seen, below normal precipitation, believe it or not. No one's complaining about that. No one's complaining about the warm temperatures because it certainly is well-deserved after the cold, wet conditions we have gone through. But things have certainly dried out. And one thing that is of relevance here is that just because we had a very, very wet water year, that does not mean that we should not be paying attention to short-term drought impacts. We're heading into the fire season here. Fuels are beginning to senesce and dry out, particularly the rangeland systems that have had above normal precipitation, above normal growth of grasses this year, also last year. Things are now drying out. We're now entering the season where we start to see lightning pick up. July 4th around the corner. So just because we had a wet water year doesn't mean that we are going to have a dead of a fire season. The one thing that we do know is that we still have snow up high in elevation, so that will lead to a delay in sort of our forest fire season. But what happens during the fire season ends up being pretty important. So that is my one short-term sort of drought early warning item that I'll throw out there. So just to summarize, we are drought-free due to basically the wettest water year we've seen in 20 years across the region. But my highlight is that we shouldn't necessarily discount that because it's been so wet. We are going to basically discount having a normal fire season. And things may become quite interesting as the next month or two evolve, depending on how precipitation shapes up, depending how ignitions shape up. So I'll end there and pass it back off, unless we want to take questions now or at the end.
Great. Thanks so much, John. We'll take questions at the end. And Amanda, if you want to turn it over to me. Can you see that?
Yes, you're good to go.
I'm going to. So this is an update that normally we give to one of our National Weather Service partners, and one of the goals of the DEWS is to connect the Weather Service with this broader climate community, which I'm involved in. But one of the things us climate people need to appreciate is that weather happens on a much shorter time scale, and unfortunately, the folks who were supposed to give this update got called away. So you get me instead, and I'll be fairly brief because there isn't really all that much to talk about right now. So I'm just going to start off with the CPC outlook for the next 3 months. This was made about a week and a half ago, and what it's showing is essentially greater odds of above normal temperatures across pretty much the entire Pacific Northwest, although when we get into Montana, we move into the equal chances territory. And equal chances doesn't mean average temperatures, it just means that the odds are weighted equally for either above normal or below normal temperatures. And this map isn't very surprising. It's for July, August, and September, and it looks a lot like what the maps for the past few summers have been showing, which is a warmer US. And we certainly got a glimpse of some warm temperatures this past weekend. We got up to 98 in Corvallis, which was a little surprising after this cold winter. But when we move on to precipitation, in the summer, we lose some of the predictability with the ocean. We don't tend to see things in either direction. And this is really showing equal chances of the same sort of thing below average or normal precipitation for the Pacific Northwest for July, August, and September. So this is tough if you're trying to plan for this sort of thing. John just mentioned fire danger and showed that we're actually dry for the past 2 months. We would certainly hope to get some precip in the summer to help stave off drought conditions and help with our fire season. But the Climate Prediction Center is saying it could really go either way. But I do want to highlight one thing from the Climate Toolbox, which John is the lead on. He has been downscaling the National Multi-Model Ensemble forecasts for the Western US. And this is a plot showing average temperature for that same sort of time period, which shows slightly higher temperatures for the Northwest, including the Oregon Cascades, parts of southern Idaho, and up into the Washington Cascades as well. But it tells a different story for precipitation, and we can get into the ins and outs of why this may be, but the CPC forecasts are developed using the National Multi-Model Ensemble, but also some statistical models and also just human inference, whatever they feel like things may be. And like I said, we lose a lot of our predictability in the summer months with precipitation, but the NMME is certainly pointing toward drier. El Nino. So a few months ago, it looked like we may be heading into an El Nino for the fall, but really it's staved off a bit. The monthly sea surface temperatures in the Niño 3.4 area, which is an area of the equatorial Pacific where we look to sea surface temperature anomalies, is slightly positive, and it just passes that El Nino threshold. Unfortunately, or fortunately, however you may be rooting for these things, you need the atmosphere to be on board as well. And right now, the atmospheric anomalies don't look like they should. Normally see suppressed convection over Indonesia, and we're seeing the opposite. So the ocean's kind of on board and the atmosphere isn't. So CPC has us at 55% odds of ENSO neutral through fall. And if you just look at the plume of ENSO predictions, these are different dynamical models and statistical models, but let's just focus in on the yellow and gray lines. They both hover right below that Niño 3.4 threshold of 0.5 degrees Celsius. So while it looked like it was going to be an El Nino, it's probably an El no-show, and neutral would be good to plan for this winter, which really means anything goes. If you just look at this nice figure that NOAA Climate put together, it takes all those different traces and puts them all together in a way that's much more visually appealing. So the average of all the monthly forecasts, again, keeps us below the El Nino threshold, though there's certainly a chance that we could pop up above it. And just looking back on what the El Ninos have looked like using this ONI index, the Oceanic Niño Index, John mentioned that we had a weak La Niña last year, and if you look at the very bottom figure at the end, it shows that as well. And you can see the monster El Nino that we had the year before. But what conditions are pointing to right now is more of the neutral, the 2014, 2013, maybe a slight bump up into above average sea surface temperatures in that area. So just in summary, the outlook shows the odds of warmer than normal for the summer, but there is a bit of a divergence between CPC and the NMME outlooks for precip. And we lose some of that predictability in the summer, especially with precipitation, but we really are seeing this trend toward warmer US summers, especially at nighttime. And ENSO neutral is expected to persist through the fall. If the atmosphere were to get on board, we might see a weak El Nino form, but I would encourage you to keep monitoring the climate.gov website as they do monthly updates on this. And that's all I have, and I'll pass it over to Gabrielle Roche-McNally, who is a fellow with the USDA Climate Hub here in Corvallis.
Well, thanks so much for having me here today. I'm going to be giving a brief presentation. I just wanted to So the USDA Climate Hubs, we're still fairly new, so it's always fun just to remind folks that we are an interagency agreement, or we're an organization, agency. We don't have a clear home necessarily, but we're funded through an interagency agreement across USDA organizations. I currently work for the Forest Service, but I really serve a broader USDA mission. And so a big focus of our work is, to communicate science-based information on climate change, specifically focusing a lot of our resources on tools and educational resources that can help managers make decisions on farms, forests, and rangelands. We focus on private landowners, but we also focus on our interagency partners to consolidate and share resources linked to reducing climate risks. What I wanted to highlight here was that we have a website here. Please take a look. Our focus is on Oregon, Washington, Idaho, and Alaska. If there are folks on the call from a broader geographic range, we have climate hubs across the US who support different regions. So I encourage you to take a look at our websites and see if there are some useful tools, resources, regional assessments, a number of educational materials, and a lot of things that are relevant to our region here or elsewhere. And then I thought I would just highlight a little bit of the seed lot selection tool. You can see the website here. I encourage folks to take a look at that. Just really broadly, the seed lot selection tool is a free web-based decision support tool, and it's really designed to help natural resource managers, primarily folks in the forestry realm, match seed lots or seed collections from a known origin, another way to think about seed lots, with planting sites based on climate information. And the tool can be used to map either current climates or future climates based on selected climate scenarios. As you dig into the tool, you can see those different scenarios. And the idea is that it will help folks to find appropriate plant sources for reforesting their land, or thinking about other reforestation of riparian areas as well, based on current and future climate information. What else do I want to share about it? Oh yeah, so yeah, we can move on. I just encourage people to take a look at the tool. Maybe at some point we'll do a more in-depth investigation of this tool. Another thing to highlight is that right now it's for the Western US, but we've expanded it to Alaska, and then the plan is there's funding to expand it to the whole of the United States. So I think it'll be really interesting once that entire suite of options are available. All right, we'll move on to the next slide. So I'd like to introduce Chris Schnepf, and he's at University of Idaho. He does all sorts of things, is a master of many trades. Obviously, he's an area extension forester, professor, and county chair. But he also has a strong interest in social sciences as well. So we have lots of good conversations on linking sort of forest management to other disciplines as well, and thinking about communicating some of these issues to a broad audience. So Chris is going to share some information based on his work. Thanks so much.
Okay. Okay, is everything showing up okay?
Yes, you're good to go.
Okay, good. So I, before talking about forestry and ag, I think it's valuable to talk about the context a little bit that extension works in, which is private forests. A lot of folks, particularly in the Western United States, presume any forest they drive through is managed by the U.S. Forest Service, and we do have obviously a lot of national forest acreage in the United States and the West in particular. But nationally, the largest portion of forests are privately owned, either by family forest owners who hold the biggest portion overall within that nationally, or by timber companies, and many timber companies are currently shedding forest lands, especially the lower sites. But even in the West, key regions have a very high percentage of private forests. For example, over half of the forests in the area that I serve, the 4 northern counties of Idaho, are private. Is forestry part of agriculture? I get this question a lot, and it seems like they almost want a confession of some sorts. And my response to it was always, is it in agriculture, or is it something separate? And the answer is typically yes, both. Kind of depends on how narrowly you define either forestry or agriculture. You know, and both are, in some ways, it doesn't matter, because both are discerning how to adapt their management practices to climate. But I guess if I had to come down one way or the other, I would say forestry is significantly different ag insofar as its starting point. In North America, we typically manage native species and ecosystems in ways that mimic natural patterns of forest growth and development. So we're managing wild systems in a sense. And that is quite different from most agriculture. There's other parts of the world where that's not the case as much. If you watch the Lord of the Rings movies and saw the pines in those forests, those were all non-native pines growing in New Zealand. You know, I think that's captured quite well by this picture of the sainted Aldo Leopold. You know, Aldo Leopold is known as the father of ecology in the United States and wildlife management. Sometimes people forget that he was actually a graduate forester, and often talks about an ecologically focused way of managing forests. But at the same time, you know, look at this picture of Aldo looking at the internode and one of the red pines he planted in Wisconsin. He's clearly got a forester's look at that as well. So I'm just going to go through a few of the biggest differences, I think, in terms of how we approach climate when we're talking about forestry versus classic production ag. Whoa, that was weird. The first is long time frames. Cereal producers can usually switch to a new variety the next year if necessary. And I've been struck by some of the discussions I've had with my colleagues in ag, and when the topic of climate change comes up, you know, they may have, you know, their opinions about it, but they feel like they're going to be able to manage it as it unfolds. Foresters really envy this kind of flexibility somewhat, because planting tree is a much longer term decision than switching out cereal varieties or whatnot from year to year. Forest regeneration cycles, typically called rotations. Length of time you're going to seedling to a tree that you would harvest. You're talking 40 years on the very most productive Northwest sites, coastal Washington, Oregon, and some of our better sites in Idaho. On other sites, it can be much longer than that. On drier sites or where for forests or where you manage primarily for something other than producing board feed, you may be talking, 125, 150 years. And of course, in the case of wilderness, maybe never. Another feature of forestry is we pretty much got to work with what we got in terms of moisture. Moisture tends to be the most limiting factor to tree growth across the Northwest. There's some places where sunlight can be an issue on the coast, but you'll almost always increase growth if you can get more water to them. Some ag producers can supplement water for crops through irrigation, not all of them by means, but it's almost never an option in native forests. Because of that, we have two main strategies in getting more moisture to those trees. One is thinking about species. They're going to be resilient in the face of historic drought extremes for a given site, and that's another theme that gives foresters some heartburn in terms of how they've been trained their whole lives to manage forests. In the sense that we typically look at our forests and we say, well, what are the worst extremes this particular site would have experienced over the last thousands of years? Well, climate change kind of changes that. So I'll come more back to that later. But the main strategy for managing in terms of moisture is what tree species for a given site are going to be the most adapted to historic drought extremes. That may or may not be the main tree species you see there right now. And then reducing stocking, thinning to reduce the number of trees competing for limited moisture. Another theme that's somewhat unique to forests is the idea of native seed sources. We focus again primarily on getting regeneration from seed sources as close to the site as possible. The idea being that those local seed sources have been selected by a wide range of historical environmental conditions the site experience. So they're going to be the best, most adapted seed sources down the road. So one way of strategy to that is relying on natural regeneration from trees on the site, and even where we do plant trees, will include some natural regeneration as we regenerate new forests. But for tree planting, the tree seed must be from an adapted latitude and elevation, and that varies quite a bit by species. Douglas fir, in our part of the world, you don't move it more than 300 feet up or down in elevation and not very far in latitude. So very tight seed transfer guidelines with Douglas fir. White pine, much more flexible, and you can really see in a landscape where they haven't had that kind of fidelity to seed source. There are a lot of areas in North Idaho where back in the 20s they planted ponderosa pine collected as far away as some say the Black Hills. And what's striking about those trees isn't that they don't make it; it's the way they don't make it. They get taken out by needle diseases and things that are normally nickels and dimers. And that provides some insights, I think, too, in terms of how we assess the effect of climate in our forests as well. I'll come back to that in a minute. Again, that traditional strategy of local seed sources weakens if the future doesn't look like the past. On some sites, the best seed source may be from a location where their past looks more like our future. So, particularly, we're not doing this here in the Northwest as much yet, but in Canada, they're already moving seed sources up mountains and from further south elevations to further north. Where you're looking at sites where the growing season starts sooner, ends later, and might those seed sources be better adapted to the future. Assisted migration like this can be kind of problematic, however. You may have a seed source that looks to be better adapted 40 years from now, and you may want to jump on that. but you also got to take a look at whether it'll handle the conditions for the next 10 years. Again, some species, Doug fir in particular, are real sensitive to frost damage and whatnot. So, how are you going to get those? If you want something that's adapted for 50 years from now, how are you going to get that to make it through the first 10 years? And that first 10 years is probably the time period where seedlings are most likely to get killed by drought or animal damage or a whole variety of other things. The seed lot selection tool, the one how developed along with some partners, was mentioned earlier, but it's really, if you want to explore this kind of thing a little bit, it's really fun to play around with that a little bit. I think we'll see more use of things like that as we start to grapple more with the seed sources. I will say, most foresters right now, we're not really moving seed sources around like too much in the United States, Northwest Canada. They are, but here I think the consensus among foresters is to still manage within the range of species that we've typically had in these sites, but then play around, reduce the density to make those species more resilient on those sites. There's a common idea that the adapted seed sources have seen especially inland, have seen quite a wide range of weather conditions from year to year that bodes well for their adaptation to some of the future climate scenarios we might look at as well. Insects and disease, there are some unique differences. With many cereals or other crops, there's insecticides, fungicides that can be used. Typically, those things aren't practical for forest management. In the case of bark beetles, which is a little mountain pine beetle here, you can't even get the chemical to the tree, even if you had something that would take it out. So our primary strategy in forestry is, again, coming back to what's the most resilient tree species and what kind of spacing is most resilient in the face of those native insects and disease. We place more emphasis on cultural practices. We're looking at biological controls quite a bit, simply because they're the only option that's out there in terms of managing insects and diseases that can be problems for us. And that foresters, I think, are particularly thoughtful about how climate change is not only going to affect the host, but also their biological controls. For example, last year in North Idaho, we had 3 generations of pine engraver beetle, small bark beetle that affects lodgepole and ponderosa pine. Normally, we only have 2. So if 3 generations a year starts to become the new normal in North Idaho, then that's something we want to look at. To tie back to something I was looking at earlier, when we look at off-site tree species, what's striking about those trees isn't that they don't make it, it's the way they don't make it. And in watching that, to me, that's one of the canaries in the coal mine regarding whether our native on-site trees are becoming less adapted. If we see things like needle diseases that are normally just taking the older inside needles on the tree, if they're starting to really impact the growth and even kill trees, well, that's maybe one indication that things are getting weird, and we may need to get more radical in terms of what tree species we work with. Fire is obviously a big deal in forestry. Natural disasters, drought and other things affect both forestry and agricultural lands. But fire is a unique issue in forestry. Since 1910, you're familiar with the 1910 fires in the inland Northwest, that changed the way the Forest Service and forestry community look at fires pretty radically. Up to that point in time, some let burn policies were more active in the Western United States. Since 1910, we've tried to extinguish nearly all forest fires immediately, and ratcheted up our technology every decade to do that. But most foresters, are well aware that fire has been a key element in Northwest forest ecology, particularly on the, but not exclusively, on the east side of the Cascades. Nearly everything, trees, understory plants, wildlife species, is adapted to fire in one way or another in its life cycles. And extinguishing fires is becoming more difficult. We have naturally heavy fuel accumulations, especially on federal lands. You know, not only in the amount of trees and down timber, but even the duff levels on a lot of sites that historically had frequent surface fires. You know, we have sites where the duff underneath ponderosa pine is as deep as 8-10 inches, where historically it would have been, you know, a quarter of that at the most. And that changes fire behavior, changes how our trees respond to fire. So there's currently more discussion of ways to allow managed fire back into these forests. And forestry places, you know, in that sense, places one public concern the same as the folks that do the agricultural burning for wheat pests and whatnot, and that's smoke. But I think there's, you know, the forestry community, we're guardedly optimistic. The idea with the concern is always that the regulatory agencies are going to shut down all burning because of the smoke pollution issues. But most of the folks that I've talked to recognize that if we can, through prescribed fire, reduce fuels out there and reduce the likelihood of, you know, a whole valley being filled with thick smoke for a month at a time, that's an acceptable trade-off. And so I'm guardedly optimistic that we'll be allowed to bring in more prescribed burning on sites that are appropriate for it. The other thing that with forestry is it's compared to ag is it's not just about the trees. You know, the non-crop things are important in agriculture too. You know, I grew up on a corn soybean farm in Iowa, and I certainly did plenty of pheasant hunting in farm fields. But even in forestry, I think it's more prominent. Even where some timber is harvested, some forest primary value may be for watersheds, fisheries, recreation, wildlife, or other values. Particularly in an era of changing climate, you know, the ability of forests to hang on to snowpack for a longer period may be their chief value in some communities. And we often have to consider those benefits as much, and in some cases more, than harvested commodities. And that's, you know, quite a degree of difference from the agricultural sector. So in conclusion, like ag, a variety of groups are discussing and researching ways to adapt forests to changing climate. A couple of options if you're interested in learning more about that. I've been involved since it began with the Climate, Forest, and Woodlands community of practice at extension.org, and we put up a variety of content to help people start thinking about climate change and how we adapt to it. And in some cases, some discussion of mitigation in the future. And then the Forest Service Climate Change Resource Center really has a lot of good content in thinking about forests and climate. And if you're interested, I encourage you to take a look at that as well. And that is it. Any questions?
Great, thanks, Chris. So now we'll turn it over to questions for all the panelists, and I encourage you to use the question box that's on the GoToWebinar control panel, and we have one there already, and I'm going to send it to John Abosoglu. It's, could the wet winter followed by a hot summer increase fire risk but allow lush vegetation to dry out?
Yeah, this is sort of the recipe typically for having active fire seasons in rangelands. And it actually ends up being a little bit more related to the amount of vegetation growth in the previous year. So certainly if you go out into the sort of the rangeland or grassland systems now, there's going to be a certain amount of green vegetation that, you know, has grown in this year. That may become available to burn, but realistically, most of the relationships that we've seen are related to the amount of precipitation in the previous year. And that previous year, if you remember last year, was also wet. So I think there's an ample amount of fuel out there this summer. Next summer will also be the same way. And certainly as things begin to dry out and we see lightning come through and July 4th around the corner, it could get interesting.
Thanks. I'm not seeing any more questions, but I'll wait a few minutes and we'll just talk about the next webinar. I realized it is 1 week after the eclipse. I woke up in a panic thinking we had scheduled it for the day of the eclipse, which will impact many of us in Oregon. But we will come back and talk about the end of summer. We'll start to think about the water year, and then we'll have another relevant research presentation from one of our partners. So mark your calendars. We'll put all the webinars and recordings on drought.gov. There's another question. And Chris, this is for you. With changing climate, tree ring climatologies may be subjected to increased scrutiny about their utility. Moisture limitations may be confounded by temperature changes too. What key Pacific Northwest tree species are reliable?
Wow, that's a great question. I honestly don't know, because trees, different species have so many different strategies for dealing with drought. Just off the top of my head, I'm inclined to think the shade tolerant species would probably, boy, it's a complicated question, because the shade tolerant species, don't tend to adapt to drought too quickly. They just tend to die because they tend to need more moisture. Whereas I guess I lean to ponderosa pine in some ways, because it can survive the really low water years and thrive during the high water years. The temperature versus moisture effect on tree growth is an interesting question. I don't know how critical it is, because the two tend to be associated with each other, it seems like.
And I'll chime in. This is John. Very quickly. It's probably not only a function of the type of tree, but where they are relative to their constraints for growth. So I think there are a certain number of sort of tree species operating and living near upper tree line that end up probably being good sort of thermometers, whereas some of the ponderosa pine that are existing near lower tree line, barely hanging on, might be better rain gauges. But it is a good point that as things begin to change, how well these basically track temperature, precipitation, or something else, that's something that people are looking into. Good question.
There's a question about any thoughts about how managers of national parks will manage their forests in a changing climate. I'll just mention that there was a Climate Central piece on national parks and climate change that was, it's done very well. So I would look into that, but I don't know any specifics. John, Gabrielle, Chris?
The national parks, the big goal is to have those lands function the way they did historically, and they're faced with the same conundrum as foresters, is how do you keep historic function on a system that's going to trend in a different direction. I guess that and I think the people I've talked to, they're focused on how they can create refugia for some of the species to kind of weather through what we might have coming. And then the others is their natural barometer for what these systems will do without human intervention. So there's some valuable role for them in that regard as well.
I know the national parks, this is Gabrielle, the national parks are doing some really good adaptation planning. I don't know if I have really specific information. I was actually trying to pull it up, but I don't know if I'll do it in the time we have. But if someone, maybe I can, on here, if we can include our contact information of the person who has the question emails me, I can try to get you more information. But I do think this whole conversation about kind of what the seed lot selection tool is doing is thinking about sort of assisted migration in a lot of different ways. And I know that for some folks that's a controversial topic, but it's certainly in the conversations that are being had, especially just in terms of species and genetic materials from specific seed lots. So looking to other areas of the country or the West where we have genetic material that might be in the same species, but that is more adapted to drought, warmer temperatures. I think those conversations are definitely happening, but there's some of this uncertainty about making some plans for these longer lived species. But generally speaking, I think a lot of folks are thinking about how do we use best management principles to create more resilient forested systems And then, you know, obviously this ties to other agricultural and rangeland systems as well that will be just more resilient generally to these more extreme and variable weather events. So anyways, hopefully my contact information can be shared somehow. And if folks want to email me, I'll see if I can find more information.
Sounds good. Well, I don't see any more questions, and we are bumping up against lunchtime here on Pacific time. So once again, I'd like to thank the panelists for presenting today. I know it's often a lot of work to put these things together. And well, thanks to Amanda, who's been helping us out, another duty as assigned for her. And she does a lot of the behind the scenes work, and we couldn't do it without her. So tune in for our next webinar, and we will talk to you then. Thanks.